Hello everyone, I am K. Nikita from 3rd year ECE department and my teammates are B. Dikshita and P. Gunashamundeshwari. As a part of internship in MLG, we have done a project on embedded systems. The project that we have implemented is car black box. Let us see the contents of car black box. Introduction to embedded systems. Uses of embedded systems. We have used a microcontroller in this project, that is PIC16 F877A, CLCD, matrix keypad, ISR, timers. What is meant by car black box? Structure of car black box, its features, internal diagram, microcontroller, required software for this project, and finally project implementation. Embedded systems. Embedded system is simply a combination of hardware and software that is designed to perform a specific task. The purpose of embedded systems is to control a specific function within a device. We use many embedded systems in our day-to-day life. For example, microwave oven, refrigerator, washing machine, etc. Uses of embedded systems. There are various applications of embedded systems like vehicles, telecommunications, etc. We have implemented a car black box using embedded systems. Softwares that are used in this project. We have implemented this project on MPLab IDE and simulated it on PiximLab using software XC8 compiler. This is the microcontroller that we have used in this project. These are the peripherals connected to it, that are LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD, analog to digital converter, temperature sensor, and finally doubly probe. CLCD. CLCD stands for Character Crystal Liquid Display. In PiximLab, we have two types of displays, that is 16 by 2 display and 16 by 4 display. 16 by 2 display means 16 characters are displayed in 2 lines. 16 by 4 display means 16 characters are displayed in 4 lines. Matrix keypad. Matrix keypad is combination of tactile switches that are connected in row and column. These are most commonly used type of switches in digital lockers, telephones, calculators, etc. ISR. ISR stands for Interrupt Service Routine. Generally, what is meant by interrupt? In simple words, interrupt is defined as stopping the present work and executing other work and returning back to the same work. Similarly, interrupt service routine. The control from the main goes to the interrupt service routine and the instructions over there is executed and written back to the main program. That is called ISR. Next, timers. Timers is a very important application in embedded systems, which is a default peripheral and which maintains the timing of operation in sync with the system clock or an external clock. Timer is a software that is designed to count intervals between the events. What is meant by car black box? Car black box is either physically installed in a car or downloaded as smartphone app. It links to the GPS device that measures and records the vehicle speed, location, distance traveled, driving frequency, and time of the day the car is in motion. Means simply, it records the vehicle speed, location, distance traveled using GPS. This is how the car black box looks like, and it is controlled using GPS. Features. It is constructed with steel armor plate. It has thick slab of paraffin. It can operate between minus 55 to plus 70 degrees centigrade. It can carry a minimum 25 hours of flight data. This is the internal structure of car black box. This is force of impact, airbag deployment, safety belt usage, steering input, braking status, throttle position, vehicle speed, and finally engine speed. Microcontroller. Microcontroller is an IC that contains microprocessor along with memory and associated circuit that controls some or all the functions of an electronic device. We have used PIC RB16F877A microcontroller in this project. It is used in many digital electronic circuit applications like remote sensors, security and safety devices, home automation, and many industrial applications. This is the hardware of the microcontroller that we have used and project implementation. After loading the code in PixSimLab, we can see the dashboard like this with time, event and speed. To record the data, we use three keys, that is RB0, RB1 and RB2. RB0 reads collision, that is accidents. RB1 reads forward gears and RB2 reads reverse gears. To see the recorded data, we have to enter the password. After entering the password, we can see the screen with view log and clear log. After clicking view log, we can see the recorded data in the below format like serial number, time, event and speed. Let me show you the project. This is the project and the type of board is PicGenius and microcontroller is PIC16F877A. Let me load the file once again. Here, this is the default dashboard with time, event and speed. From RB0 to RB5 are tactile switches. These are the LEDs, these are potentiometers, this is W probe and this is the microcontroller. This is RTC and this is reset button. Now, by clicking RB0, it records collision. So, event is C. RB1, normal gear, reverse gear, gear 1, gear 2, 3 and 4. Similarly, by clicking RB2, we can record the reverse gears. G3, G2, G1, GR and GL. Now, let us view the events. To that, we can click any of these two buttons. I have clicked RB3 and password is RB4, RB3, RB4 and RB3. We can view the screen like this, view log and clear log. Now I want view log, so that I have to select OK by using RB5 button. Now this is the serial number, time, event and speed. We can increase by using RB4, 1, 2, 3, 4 and 5. We can decrease it using RB3. Now let us reset it and clear the blocks. To clear the blocks, we have to enter the password once again. And we should select RB4 and now OK. So logs cleared successfully. Now let us change the password. To change the password, we have to click RB4 once again and click on RB5. Now we will create a new password, that is RB3, RB4, RB3 and RB3, 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 RB3. Now password changed successfully. This is our project. Thank you for giving me this opportunity.